Hello. So here we are discussing BFS Traversal, which is a graph traversal. And in this type of graph traversal, what we do is we start from a particular node. Let's say this one, and then what we will do is we will visit all its adjacent nodes, right? Then after that, so let's suppose we call A as level 0, right? Then what we will do is its immediate neighbor, call them as level 1. So they are at level 1, right? 6, 2 and 5 all are at level 1. We have traversed these level now. There is no other directly connected node to 1. So now what we will do is we will traverse all the neighbors of directly connected node of 1. That means we will be going to all the adjacent nodes of node at level 1. So first let's check for 6. So 6 is directly connected to 1 and 7. But as we know that 1 is already been visited, already traversed, so don't need to go there again. So go to 7. Now 7 is at level 2, right? Then 5, then we are at 5. So 5 has only one neighbor which is 1 and it is already visited and it has nothing else, so just leave it as it is. Then what do we have? We have 2. So what we can do with this, we can go to 1 but 1 is already visited, so then go to 3. 3 is at level 2. Then go to 4. 4 is also at level 2, correct? So now all the nodes which were of level 1 are now traversed. Now we have 4 and 3 as the level 2, which is currently minimum unvisited, also 7. So now what we'll do is we will again check the neighbor of current level, which is 2. So let's go with 7. So 7 has no other neighbors except of 6, but 6 is already visited, so it's done for 7. Then similarly for 4, 4 is connected to 2 and nothing else, and 2 is already visited, so then just go to 3. Now 3 has two neighbors, 2 and 8. So 2 is already visited, so let's forget it. Then 3 is having another neighbor which is 8. So just go on 3, they go on 8, and 8 is now at third level, right? Now only node with level 3 is 8, right? So now all the level 2 nodes are done. Now go on level 3 node, which is 8. Check its neighbor. Its neighbor is 3, 9 and 10. 3, 10, 9. 3 is already visited, no need to visit again. Go on 9. 9 is now at level 4. Then again go on 10. So 10 is at level 4. Now all the nodes of level 3 are done, which is 8. Node number 8, it is done. Then go for next level, which is fourth level, and two nodes are there. One is 10, one is 9. So neighbors of 9 is only 8, which is already visited, so done. No need to do anything because nothing is there. Then for 10 it is also same thing, only 8 is connected to 10, so this is also done. So that is it. Now how do we, yeah, so as we can see, all the nodes are all the nodes are visited, as you can see through the diagram. Now how did we traversed? So first we were at 1, then from 1 we went to 6, then went to 5, then 2, correct? Then after that we went to 7, we went to 4, we went to 3, right? Then we went to 8, we went to 9, and we went to 10. So this is a breadth first search traversal of the given tree. And as you might have guessed, we can do as much different types of traversal as we can by just simply changing the order of visit or changing the starting node. So what do I mean by that? Let me just erase something. Yeah. So now let us. So what was I saying? So we can do multiple types of different types of traversal. So now let us assume we are starting from 2. Then what we will do is we will go to 1, 4, 3. Then from 1 we will go to 5. Then 6 and 5, and 4 has nothing. So then from 3 we will go to 8. Then again for next level we will go to 7, then 9, then 10. And in this way we have another traversal which goes like 2. From 2 we are at 4, we are at 3, we are at 1. Then what did we do? We went to 5, we went to 6, we visited 8. Correct. Now for next 7, 9, 10. So this is also a valid breadth first search of same graph, but we used what you can say, we used different starting node. Correct. Now also what we could do is we like visited in this, like in the given graph we can see that we went to 4 first, then 3, then 1. Correct. uh, we can do 2, 1, 3, 4. So this particular same level, like they are on this same level. As you can see, they are just neighbor of 2. So 4 is connected to 2, 3 is connected to 2, 1 is also connected to 2. So they are immediate neighbors to 2. So that is why we can visit them in any order. So you can push this thing, then you can do 2, 1, 4, 3, and like many more combinations can be done. Accordingly, you will follow the next step. But one thing, if you are processing 1 first, then 3, then 4, then next, like this level is done, then the next level should be, first you will follow the neighbors of node 1. They will go here, then neighbors of node 3, then neighbors of node node 4. Also, if there are multiple neighbors, then also we can generate many more such patterns. But the basic thing is we have to follow this order, that if we are processing a certain node prior, then its neighbor should be generally followed, uh, generally be processed next. But this is not like entirely true. We can do as we like, but the level should be there. Like the level has to, like the nodes with same level has to come, uh, like has to be there with each other. Like we cannot put a second level with one, and then third is, and again one is there. This is not a valid BFS. So like, like this was zeroth level, this was first level, right? This was first, then mm, this was second, third, and fourth, right? So this is for, these are the levels. Now let us think how we can like do this thing, like how we can come up with this using code. So what we can see is we are first traversing all the neighbors, all the immediate nodes, immediate connected nodes of a given node. So and then we are processing it one by one. So what comes in our mind is, firstly we are suppose at node uh, any node. Suppose we are starting from 2. Yes, then what we are doing is we are storing all its neighbor 1, 3, 4, right? Then this job of 2 is done. 2 is already traversed. Then next thing what we are doing is now we are taking out each node one by one. So then what we are doing is, suppose we have taken 1 out, right? Then we will process all the neighbors of 1, which are 6 and 5, and they are next level, so they should be followed by 3 and 4. So now our structure looks like 3, 4 we have. Then we are processing 1. Then what we'll do is we will push 5 and 6, which are immediate to 1 in the processing. So like if we are at 1, then we will go to 5, 6 and 5, correct? So this is, then let me just change the color of pen so for these. So now, yes, so now this is done. Now what we are doing is we are checking for 3. So what we'll do is we go to 3. So here we are. Now we will go on its neighbors, which are, oh sorry, which is just 8. So we have to process 8, but after these elements are done with processing, so we will push 8 here. So this structure simply, as we can see, is we are pushing elements, then we are popping from front. So it is simply a queue. Yes, it's a queue data structure. So what we should do is, so if you have got the gist, what we have to do is we have to first start with a node. So assume this is a queue. So we will push a node. Then what we will do is we will take out the front of queue, pop it, and check all its adjacent, and then push them a1 adjacent to. So that is what. Then after, then in the next time what will be there, node is gone, we have a1, then we have a2. Then what we'll do is we will push pop a1, then all its neighbors, suppose only b1 is there, then we will like push b1 to process. Then we will process a2. If suppose it has none, then its processing is over. Then we have b1, and b1 has again some of its adjacent nodes, then push it back, again process them, and so on. So this is the basic logic behind the BFS algorithm that we can perform. So what we'll need is we'll need a let me just change the, oh yeah, uh, so yes, what I was talking is, so firstly basic thing is we need a adjacency list, which is generally given in the questions. We don't need to worry about it. Even if it is not given, we have to like make adjacency list, so that is not a big task. Then what we'll do is we will take a starting node, push it into queue, push start into our queue, suppose like in queue. Then what we simply do is we have to process all the nodes until all nodes are done with the process, like all nodes are done visiting. So what we'll do is we can simply use any loops, we can use a while loop with a condition like q. Suppose uh, q dot sorry, q is never empty, right? So that's, I'm writing a pseudocode. So we will loop until the queue gets empty. Then what we have to like, then we have to pop its front of the queue, which is suppose mm, a node, which is current node, right? And it is queue dot front. right? So we have queue front of queue. Then what we'll do with this is the we have adjacency list also. So for int I adjacency list of node. So we are at node. Then for all elements of adjacency list, we will simply check. Oh, also one thing I forgot to mention here. So you all must be knowing what is a visited array. So we need another thing which is visited array, as we are familiar with it, or else let me just explain you in a bit. Yeah. So what is a visited array? So we, in the given question, what we had 10 nodes and starting from 1 to 10, so we will require a size 11 size. Just make let me make one. We required a 11 size array, or what you can say, yeah, array only. And this is okay. Just a minute. So ignore the upper part. mm, yeah, yeah. So now we have, so this up first line is of showing index, right? Second index, then we have third, then fourth, then 7, 8, 9, 10, right? 10. Then these are all indices, right? These are all indexes. IDX. Hmm. And initially, what this is our visited array. Firstly, visited array. Initially, we all cells are of value 0. Now, what does the value 0 mean? The value 0 signifies that the current cell is not visited. So, firstly, what we had was this one was not visited, and 2 was not visited, and so on. So, let me just so uh, okay. So yeah, we have our graph with us. So now what we'll do is we'll see how to like uh, do BFS on this. So firstly, what we can do is we have our first node as starting. Let us assume we are starting here. So first task will be make our visited of one as one, right? Then we will go to its neighbors, store it in the queue. So how firstly our queue was, suppose it was one. Uh, okay. So this is queue. We pushed 1, then we have popped it, also made it visited. Then what we did is we pushed 6, then 5, then 2. Right. Now what we'll do is we will now process 6. Firstly, we will make visited of 6 as 1. Then we'll pop 6 from our visited our queue. Now process 6. Now that what processing of 6 means, check all its neighbors. Now who are neighbors of 6? Neighbor of 6 is 7 and 1. Now check in visited array. So visited of 1 is not 0. That visited of 1 is 1, right? So that means it is already been visited. We don't need to visit it again. We don't need to process it again. So just leave it as it is. Then we have 7, which has which has visited value 0. That means 7 is not yet been visited. So what we can do is simply push 7 after 2. Correct. Then 6, traversal of 6 is over, gone. Then again pop the front of queue, which is 5. Now firstly make visited of 5 as 1. Then now check all its neighbors. It has 1, but visited of 1 is already 1, so no need to do anything. Nothing else is there with 5, so just forget it. Then what do we have? 2. So first we are now processing 2. Firstly make its visit value 1. Now then it has neighbors 1, 4 and 3, but 1 is already been visited. Now what we can just do is push 4 comma 4 and 3 into queue. Correct. Now all neighbors of 2 are done. True is now processed, gone. Now what do we have? We have 7. So pop 7 from queue, make its visit, like make its value at visited array 1. Done. Now we have 7 is connected to 6, but 6 is visited of 6 is 1, as we can see in the visited array. So no need to process again. Nothing is left. Now check for 4. Pop pop 4. Now make visited of 4 as well. 4 is connected to 2, but visited of 2 is already 1, so that's it. Then again go to 3. Like what is there remaining in the queue is only 3, so pop 3, make its visited value as 1. Now go to its neighbor. Now 3 has 2 and 8, but 2 is already visited, no need to bother. But 3 has 8, so push 8 into our queue. Hmm. Now what do we have? 3 traversal of 3 is done. What is remaining there? It is 8. So yes, take out 8 from the queue. Make it visited 1. Now visited of 8 is 1. Then go to its neighbor. 3 is already been visited as its value is 1 in visited array. Then go to 8, 9 and 10. Push 9 and 10 as visited of 9 and 10 is 0, as you can see. Correct. Now go to 9. Visited of 9, make it 1. Check its neighbor, it is 8, which is already 1. So that's done for 9. Now for 10, uh, visited of 10, make it 1. Check its neighbor, which is 8, and it is also already been visited. So yes, done. Now what do we have in queue? We have nothing left in queue. So that what means is our uh, yeah. So this condition is now hit, and we will be thrown out of the loop, and our traversal will be over. So that is how we can do BFS. Now let me show you like what I have missed. So firstly, declare a visited array. It can do vector or array, whatever you want to, and it's a pseudocode, so I'm not doing all those things. So simply it's int visited. Now where were we? So we are in, firstly we have like pushed our starting node into queue. Then while queue is not empty, then each time we are taking like queue's front, then we can immediately pop, or also we can pop after the job is done, at the end of loop. But uh, yeah, we can do it afterwards, no issue. So if uh, adjacent, if what we were checking is if visited of I is 0, that means it is not been visited yet. So in that case, what we can do is q dot push I, else though it will be visited only. After this loop is done, we can do is visited of node equal to 1. That means we will be making sure that next time we are coming on this node, it is already been 1. And also q dot pop, that means this node will be gone from queue and we will be moved to next queue, and this job is done, just return or whatever is there required. Also one thing, in standard practice, this these two lines, they are preferred here, so at the start, so you will find it everywhere and it won't make any change. But I forgot to mention these lines, write these lines above the for loop, and this code will work uh, like as fine as it should be. So no issues with that. On that note, thank you. Thanks for watching.